In this episode, we discuss the role of open source in building industrial IoT solutions. We discuss why open source matters for addressing challenges of IIoT implementation. We discuss the open source IIoT stack, open standards for data aggregation, why semantic interoperability is important for the success of IIoT, and we also discuss MQTT Sparkplug and its value to implementers and end users. My guest on this episode is Frédéric Desbiens. Frédéric is working at the Eclipse Foundation as the program manager for IoT and Edge Computing. His job is to help the community innovate by bringing devices and software together. He is a strong supporter of open source, and in the past he's worked as product manager, solutions architect, and developers for companies as diverse as Pivotal, Cisco, and Oracle. Frédéric holds an MBA in electronic commerce, a BAsc in computer science, and a BEd, all from Laval University. Quick thank you to our sponsors. This video is made possible by our friends at HiveMQ, who are providers of an MQTT broker. Please do check them out on the link below to help support this channel. Welcome to the 4th Generation podcast here on Industry40.tv, which is a series of weekly interviews designed to help you learn IIoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kudzai Manditereza. Now, here's my conversation with Frédéric. So, Frédéric, thank you so much for joining us today. I would like to welcome you to the show.
Thank you. It's great to be here.
Awesome. Okay, so today I really want to speak to you about the role of open source in building industrial IoT solutions. So to start off, what do you see as being the key challenges when it comes to implementing industrial IoT solutions?
Industrial IoT is certainly a complex landscape, right? Because the one thing that you have to understand when you think about it is that the time frame for industrial IoT is completely different than for your typical IT project. Typically on the shop floor or factory floor, when will you rip up and start a new, right? Maybe once every 20 years or something, or even longer than that. So typically when you do industrial IoT, you have to deal with lots of legacy technologies because there are massive capital investments in those machines and everything around. And then on the other end, there is actually more and more pressure to modernize, right? So you need to integrate new technologies alongside legacy. They don't play well necessarily with each other. And obviously, there are efforts to try to streamline that, and OPC UA is an example of that. And I think you had some deep dives into that with in other episodes of your podcast. But the problem with that is, even in those specs that try to streamline things like OPC UA, I mean, the complexity is staggering there. The OPC specification being over 3,000 pages, so it's a lot of things to integrate. And then, obviously, another risk there or key challenge is that although we see more and more openness in that market, there are some large vendors that play proprietary strategies up to a point. They will support some open protocols, but they try to push their old style legacy things. And navigating all of that, especially if you are starting in the industry or if you have a smaller team, is not necessarily easy. But in the end, to me, the key thing to remember is that essentially openness creates real robust ecosystems. So if you are just starting about modernizing and integrate new technologies on your floor, in your infrastructure, the one thing to remember is that the only ecosystems that will win on the long term are those who are actually open, in the sense that, think about it in terms of bread, okay? Yeah. Bread making, we don't know when it happened. It's lost in the midst of history. But what makes bread incredible is that wherever you go in the world, you can have local breads that are special that you won't necessarily have home, and all sorts of traditions. This diversity is incredible. Yeah. Now think if bread making had been a closed secret and only 5 big companies in the world could offer you bread. The whole bread ecosystem would be much more boring and less useful and less even profitable in a commercial perspective. So it's the same for software, right? Yeah. In the sense that if you have a closed ecosystem, then you don't have as much competition, as much innovation, and overall everyone is losing in a scenario like that.
Oh, okay, awesome. Okay, so you have already touched quite a bit on the advantages of openness when it comes to then implementing an industrial IoT solution. Why would it matter to use open source, as opposed to proprietary technologies?
Yeah, there are many advantages there, but let's say that I have the chance at the foundation, we do surveys all the time. One for commercial adoption, typically early in the year, and one targeted to developers later in the year. So we are just about on June 8th to publish the results of our 2021 commercial adoption survey. And we asked this question to people: why is open source valuable to you in IIoT scenarios? And essentially the top 3 answers, were this. Customization was number 1 at 29%. Cost was second at 19%. And then more control was third at 14%. And to me, this is significant, and people could only pick one, right? So, overall, there were other answers, and it adds up to 100%. But what is fascinating there is that you see, yes, cost is a consideration, but it was number 2. And when you look at customization at number 1 and more control at number 3, then you have, the more compelling reasons. IIoT is all about getting the right type of hardware, the right type of integration at the right price. And to that, having features that you won't use and all of that, that's not something you want to pay for. So the fact that with open source, you can really tailor the software and even the hardware now with all of the great RISC-V and other open source hardware technologies. Even in modulation, you have -7, which uses an open modulation. Anyway, all of that means that you can really tailor your solution to the use case. And then more control is important as well, because essentially, when you think about industrial IoT, I keep repeating myself, it's different from IT. Why? Because the time frame is longer, it's heterogeneous, you have to integrate hardware from various vendors. No one is a one-stop shop in that market. There are many physical constraints like power consumption, dust, vibration, etc. you need to take into account. And obviously the network is something in the sense that you have to engineer around the fact that maybe your network won't be as reliable as you wish for, and then you need backup strategies, things like that. And open source addresses each one of those things. The time frame, when you have the source code, you can maintain things over the long haul, even if commercial support is dropped. It's heterogeneous. Well, it's easier if you have the source code for all of those hardware and even software components. The constraints, well, you tailor because you have the source code. And even in a networking perspective, it's much more easier and you have more freedom of choice to pick the right networking technologies when the underlying layers are open source. So for all of those reasons, open source is the right way to go there.
Interesting. That's quite some interesting stuff there. So now when it comes to the composition, the actual composition of an industrial IoT solution, what would you say are the key components of putting together an industrial IoT solution?
Oh, gosh. So obviously it's hard to generalize there, but I will try. First, you have to start with the right development tools. I mean, that's often something that's that's forgotten. But when you pick a specific platform, paying attention to the type of developer tools that you are getting is really important. And at the Eclipse Foundation, we've had a success story there in that market for a long time with the traditional desktop IDE. Our C development tools, have been adopted by most of the vendors in the market, like NXP and STMicro and all of the others. They have Eclipse-based solutions for you to develop on their boards and things like that. But now what we see emerge is that there's a new wave of cloud development tools, so browser-based development environments. And embedded vendors see a lot of interest in that because essentially, well, it's simpler to onboard new team members when you don't have to install, tons of developer tools on the machine. You just go to the website, you plug the board, and then you can interact with the tools. So that's why in our cloud development tools working group, which is not something I care about, that's my colleague Brian King, but they've got an embedded SIG there, a special interest group of tool builders that really focus on embedded. So the development environment to us at the foundation is critically important. Then, if we take a step back and look in a wider perspective at the architecture for industrial IoT, you start by picking the right sensors and actuators for your job and the constrained devices that you will drive. Whether it is a retrofit project where you add sensors to older legacy machines or pick brand new machines with capabilities, compute even capabilities built in, paying close attention to that and to the openness is one important first step. Then, obviously, you need to think about the protocols you will leverage. At some point, I was on the advisory committee for a conference, and we were judging sessions, and I could see the comments of other judges on the sessions. And my own sessions was about picking the right protocol for your industrial IoT project. And someone made the comment, hey, when you use this platform, I will I will censor the name of the platform, but when you pick this platform, you don't have to pay attention to the protocol, right? It supports everything. Well, no. I mean, depending on what you're trying to achieve, you need to pick the right protocol for the job. And there is so much variety there, whether it is OPC UA, CoAP, MQTT and Sparkplug, etc. I mean, being really intentional about what you pick there is critical. Then, obviously, you need to pay attention to what kind of gateways and edge nodes eventually, if you do edge computing, you will deploy, because especially if you need to bridge legacy with more modern technologies, the gateway and edge nodes, they play a critical role in making everything secure and making it possible to integrate stuff, and ultimately then there's a question of whatever IoT platform you will use. And there, my preference will always go to platforms that you can deploy, whether it's on a virtual machine or containers, in a very flexible way. There are great things that happen in AWS and Azure and Google Cloud and things like that.
Yeah.
But let's say that as an open source advocate, I'm not necessarily objective on that question, but I would be wary about leveraging those very cloud provider specific IoT platforms. At least, maybe you can push some of the data there if you see features that you like at a price that you like. But, in a data sovereignty perspective, for example, I wouldn't use that as the main hub for all of my business critical data, for example.
Okay, that's quite interesting. Now, you mentioned the edge computing and gateways, and to a certain extent, the hardware part of IIoT gateway has been commoditized. Now, it's more dependent on the software for core functionality of IoT gateways. So, what does that open source tech for IoT gateways look like for you?
So essentially, we see two schools of thinking there at the Eclipse Foundation. One is about having a pre-integrated gateway plus IoT cloud platform stack built together. And then the other approach would be to use container orchestration on the gateway or at the edge, okay? So when we dig a bit deeper, when I talk about the pre-integrated stack there, this is, those are at Eclipse, the Eclipse Cura and Eclipse Kapua projects. So Eclipse Cura is a Java/OSGI based gateway platform that you can deploy on any ruggedized hardware with the proper connectors that will run Linux, essentially. And it's written in Java, so it's portable and will adapt to a variety of environments. It's great because out of the box, it will come with connectors for most of the major protocols. And obviously, the OSGI stack is a very mature stack that you can use in order to build your own extensions to the platform. So obviously, our friends at Eurotech are not only using Cura, but selling everywhere software platform as a commercial offering on the top of it. But even the base open source version is fully featured enough that anyone could leverage it and build solutions around it, no questions asked. What is interesting recently in the Cura ecosystem is that we've seen some Eurotech partners starting to contribute to the project. Recently, we had a French company called Stir1 Technologies, and they contributed a new Wi-Fi component to the platform, and they are building their own gateways with another partner. So you see this ecosystem growing in an open way, and it's great. And then the Kapua platform that goes along with it, it does device management and data management and things like that. So you have really an end-to-end solution that's really great for very small organization or even larger ones. And it's a mature one. That's one of the first projects we had at Eclipse IoT. Then there's the angle of doing container orchestration in the sense that maybe what you want is to deploy very, very specific software components that are not necessarily written in Java and things like that. And then we've got a fantastic container orchestration platform that's called Eclipse IO Fog. Eclipse IO Fog, can run in standalone mode, and then it will use its own container runtime to run the containers locally on various nodes orchestrated with a central controller. And then you can integrate it with Kubernetes, and then you can spread out the workloads from a central control plane, but you don't have to install Kubernetes on each of the very small nodes, which is something I wouldn't do personally, but to each his own. In any case, this is a bit a more generic approach, but very flexible in the sense that whatever you can containerize, you can deploy. And then typically any node that will run Linux, and as you mentioned, this is a commodity and Linux is a commodity. So you have plenty of choice at very, very good prices, even for ruggedized hardwares. So both approaches have their value and saw great success in our ecosystem at Eclipse.
Oh, okay. So now, data aggregation is a key aspect, really, in that in building an industrial IoT solution. So, what open standards are available for data aggregation?
There are so many of them. And typically what we do at Eclipse IoT will integrate with the great innovations that are happening for data management and big data and things like that in the market rather than reinvent the wheel. So what we've seen in our ecosystem is a lot of people integrate, for example, with Apache Camel or Kafka or platforms like that in order to process messages in a certain way and then distribute to specific databases. And the same with Hadoop and larger data marts and data stores. One interesting thing that we've seen emerge, however, is really what people are trying to do with this data. And so essentially, the way that people specifically will start doing AI in a multi-tiered way, where essentially you do basic analytics, let's say on a video camera, straight on the camera, and then send an aggregation of that somewhere, and et cetera, et cetera. But the big problem there is that most of the AI platforms, most of them are open source. TensorFlow is open source and things like that. So there are ecosystems around this, but there's not one single solution there, and going from one framework to another will be complicated at times. So what's interesting is that we've seen, for example, in our Eclipse ecosystem, people that start leveraging the OPC UA data models, for example, and rather than use the full OPC UA stack and protocol, they just take out the data representations, and then they will put that on the top of something else like our Sparkplug protocol. And in fact, this has been demonstrated by the Advanced Manufacturing Center at Sheffield, at the University of Sheffield, one of our members. And that's great in a great and innovative approach, that picks the best from the open source ecosystem to drive solutions. Another thing in data, another very interesting trend that we have seen is that part of the problem with data aggregation is you want to aggregate things and make things available and being able to query them. But at the same time, you have data sovereignty requirements where maybe I don't want this data to get out of this factory. I don't want this data to get out of this country or out of the European Union or any kind of those scenarios. The thing there is we've seen a very innovative project at Eclipse called Eclipse Zeno, which is a pub/sub protocol. So like a bit like MQTT, let's say, or DDS, because Zeno doesn't have the concept of a broker, but it's completely decentralized. Then you attribute the role of a node as a client, a router, or an aggregator, etc. But what's great about Zeno is that it integrates the principle of distributed storage. So what's happening is that when you create a storage node in there, you have a number of plugins that enable you to pick from any number of open source SQL or NoSQL database. So you use the right storage engine for the job at a specific location, and then built in the protocol are capabilities to query transparently over all of those locations and in some cases you can even have this shared data space, that will go across the old mesh of nodes. And I mean, that project is really awesome. And to me, it is really the direction that we are heading to. Maybe we won't aggregate necessarily everything in the future, but we'll try to keep some of that data in the right location and make it available through standardized APIs like Zeno does, for example.
Okay, that's quite interesting. I should really check out Zeno. It sounds so awesome, eh?
Absolutely. You can visit their website on zeno.io.
Now, a hot topic in IIoT is that of interoperability, particularly semantic interoperability. Now, what I would like to know is why is interoperability so important for the success of IIoT?
And essentially, there are two important things there. The first one is that anytime that you spend integrating your devices and the various software components that you have in your architecture, you're wasting time, you're wasting money, literally like that. It's not a productive use of your time, and you're not creating value when you do that. You're just doing what the suppliers should have done, which is to provide interoperability out of the box. The second reason is that data is really worthless without meaning, without context. It's great to have all of those numbers, but if I don't know what this is, then obviously I cannot, once again, extract value, make better decisions, improve my industrial processes or anything like that. So it's so important to have interoperability, because then you don't waste your time integrating things, and then your data is really valuable, because the fact that you have this semantic meaning throughout the whole chain of components that you have in your architecture really is what makes it valuable. And a third reason would be simply, as I mentioned, an ecosystem is only valuable when it is open. And so if you have to translate between data models or anything like that, then obviously you're not as open as you should. Then definitively that's a weakness that as a manager or an architect you need to address in order to go forward.
Oh, okay. Now we're talking about interoperability. You are part of the MQTT Sparkplug working group, which seeks to achieve interoperability in IIoT. So in that regard, I've got two questions for you. First of all, what I would like to know is what is the real value of Sparkplug to implementers? And then also I would like to know what is the real value of Sparkplug to end users?
Yes. So for people maybe listening who are not familiar with Sparkplug, let's take a step back a bit and talk a bit about MQTT. MQTT, PubSub protocol, has been around for over 20 years now, very mature. You have a number of open source solutions and commercial solutions in the place. So it's great. One of the great things about the MQTT specification is that it doesn't tell you anything about the payloads for the messages that you are sending. So it's very flexible. One of the bad things about MQTT is that it doesn't say anything about the payloads. So you are receiving those messages and you have no idea what this data is about. So the whole point of Sparkplug is to address that. It does three things in order to create interoperability out of the box in the MQTT ecosystem. And those three things are, first, it defines a set of generic standard payloads, but that you can extend in a standard way in order to really address your use case. And a great example of that is what University of Sheffield has done by using the OPC UA data model and putting that on the top of Sparkplug, as the Sparkplug protocol lets you do. Then Sparkplug defines a standard set of topics. So essentially, a topic is the place where you publish or your information or you subscribe to. And once again, this is free form in MQTT. You can name them anything you want. So this is a robot telemetry, or this is Star Trek, or whatever. I mean, it's completely arbitrary. And so out of the box, you have no idea what would be the topic that your new robot will want to publish to or subscribe from. And that's a problem. So Sparkplug once again defines a standard hierarchy of topic structures. And then the third thing that it does is to add stateful session management on the top of MQTT, which is something that you don't find in the base protocol. So all of those three things are really critical to make MQTT infrastructure interoperable. So what are the advantages now for the implementers of Sparkplug? First, it's the faster time to market, right? In the sense, Sparkplug is an open source protocol specification at the Eclipse Foundation. And you just, you can implement this freely without having to pay any royalties to anyone. And obviously we have an open source implementation. So in the Eclipse Tahoe project, so you can just pick up Tahoe and then integrate that to your stack, and wham, you have already Sparkplug compliant. Then there's the simplicity in Sparkplug. We talked about OPC UA, and it's a great thing, but it's over 3,000 pages long, which means if you are a new entrant as a software publisher to the market, you have to master all of that, and that's intimidating. The Sparkplug specification is less than 100 pages. So its inherent simplicity means that it's certainly easier to implement and easier to maintain and integrate. And then what we're about to introduce in the second part of the year is the Sparkplug compatibility program. So essentially, there will be an open source technology compatibility kit, or TCK, like on the model that we've got in the Java ecosystem with OpenJDK. So OpenJDK is Java compliant because it passes the Oracle TCK for Java. So we'll have the Sparkplug TCK developed in open source. And people will be able to download the binary of that under another license so that you wouldn't modify the TCK at runtime. And anyone will be able, if they have implemented Sparkplug, to pass the TCK and then get an official result that you are compliant to the standard. And then if your code does that, you can join the Sparkplug working group and the Eclipse Foundation and be part of the compatibility program. And then you have those Sparkplug compatible stickers that you can put on your devices or on your website. And, we are creating an open ecosystem there that really will have value, so that if you are then in the market for gear or in the market for software stacks, you can pick from our compatibility page that will appear on the Sparkplug website and be sure that things will work out of the box. And that's the whole point of the initiative, interoperable MQTT infrastructure.
Oh, okay, awesome. Awesome. So maybe while we're still on that topic of Sparkplug, one of the main concerns in the industry, in fact, I actually saw this in one of your posts on LinkedIn. It is this idea that binding Sparkplug to a single protocol like MQTT might cause problems in the future. So what efforts are there to future-proof the Sparkplug if it needs any future-proofing at all?
Yeah, absolutely. Well, this whole debate about Sparkplug being tied to MQTT to me is a bit of a sideshow, in the sense that how would I say that? MQTT, when you take a step back, this is an open standard. Okay, this lies at the OASIS consortium, and it's built in the open by a wide ecosystem of commercial and open source players. So, locking yourself into to MQTT means that, well, that's not really lock-in, because you have so many choices and so much maturity in there. And then with the emergence of MQTT SN, one of the worries about MQTT is that it's tied to TCP/IP, which means obviously in low power scenarios and things like that, maybe you are consuming a bit more energy that you would like. So now we've seen work on MQTT SN. The SN there is for sensor network that will decouple MQTT from TCP/IP and bring it to UDP and other transports like that. So right now, Sparkplug is not necessarily compatible with MQTT SN, but you can expect, if there is demand in the market, right? If that's a concern for people, that you will see that appear at some point. And in any case, if you care about that, let's say to the people listening or watching us, if you care about that, you can propose such changes to the Sparkplug specification. It's built in the open on GitHub. So you literally submit a PR on GitHub on the spec to propose new features and things like that. And then it's up to the project team to decide. But still, this is an open thing. So Sparkplug, yes, is building on MQTT, and there's a good reason for that. The Sparkplug specification would be much more complex if we were specifying our own low-level transport protocol beneath Sparkplug. So by building on a well-known and mature protocol like MQTT, we make Sparkplug much simpler, which is one of its main draws. It's easy to implement because it builds on all of the great innovation in MQTT. And to me, that's not necessarily a problem. Because eventually, if there are other protocols that are better than MQTT that appear in the market, since Sparkplug is an open source specification, nothing prevents you from taking the base data structures and principle and try to adapt that to another protocol. But we don't see necessarily a demand for that, in the sense that it's great to tell, hey, my protocol can use TCP transports and non-TCP transports, but do people in the field really are asking for that, or are they asking for interoperability and simplicity? To us, they are asking the latter two rather than just a nice theoretical, so to speak, flexibility in the transport layer. More than that, I told you a bit about Zeno as a protocol before, and what they've been doing. The guys building Zeno have a deep investment in DDS as a protocol, and what they've done. Since DDS doesn't route well over the public internet, it's very good in closed networks, but it's very difficult to route if you need to bridge two separate locations over the public internet, and then you have to deal with lots of network complexity. So Zeno can encapsulate DDS with very, very, very little overhead. Okay. And then Zeno itself supports a variety of flexible protocols, like it supports TCP, it supports UDP, it supports the new Google Quick innovative transport there. So you've got a choice. So eventually, nothing would prevent you, for example, to do Sparkplug over Zeno, for example, if you absolutely want, for whatever reason, to be decoupled from, a specific lower layer transport protocol. So there are a variety of approaches there, but ultimately, what drives us at the Eclipse Foundation are not theoretical concerns or academic discussions. It's about real developers trying to do things in the market. And right now, people are quite happy with MQTT, and people now are quite happy with Sparkplug because it solves real issues for them when they're trying to implement real projects in the real world, not discussing theoretical advantages on LinkedIn or elsewhere.
Awesome. I mean, that makes quite a lot of sense there. Thank you so much for that answer. Moving on, one area of IoT that I'm personally researching on is digital twins. So can you tell us about open source digital twin frameworks that are available and how they work briefly?
Yes, absolutely. And there, unfortunately, I can speak mostly about what we are doing ourselves at the Eclipse Foundation. I know there are other things that exist, and maybe I will miss part of that because, well, I'm already juggling 3 working groups and 50 plus open source projects at Eclipse, so that's enough to keep me busy. But essentially, we have at least 2 major projects that have deep support for digital twins at the Eclipse Foundation. One is Eclipse Ditto, which is literally a framework for digital twins that has been contributed to us by Bosch, so a major industrial player in Europe. And then there's the Eclipse Cura framework, gateway framework that also has a support for digital twins. So obviously the Cura approach is really, how would I say that? Cura is a great product with a great web-based user interface, and you can log into that and then do your device definitions and things like that. And there are some import mechanisms. And really, devices are a first-class citizen in Cura, in the sense that there are many features that are built around them, and the Capua IoT platform that goes with Cura is able to manage those actual devices that would be in the field. So you model them, so to speak, in Cura, and then you can manage the actual devices that you are building things from in Capua. And then, going back to Ditto. Ditto is a digital twin framework which is open and has direct integrations with MQTT, for example, so you can get the real data straight from there or use Ditto with other components. But really, what is fascinating about the Ditto approach is how they fit digital twins in their overall IoT framework at Bosch. So Eclipse Ditto is accompanied by other Bosch projects, or I shouldn't call them Bosch projects. They originated at Bosch, but obviously now they are in open source, and they have a strong open source community around each of them. But essentially, the 4 components there are Ditto for digital twins, Eclipse Vorto for modeling, Eclipse Hogbit for device updates or software updates over the air, and Eclipse Hono as a high throughput, highly scalable message routing platform. And Hono speaks multiple protocols and converts everything inside to AMQP or Kafka, depending on what deployment model you prefer. So Ditto is a part of that. And what's fascinating is the whole workflow that they've implemented in open source. So Eclipse Vorto, as I said, is the modeling environment, and it's got a domain-specific language where you define the properties of your devices. You can export straight to code from that if you want. So it's got code generators for C and Java and things like that. But you can export that to a Ditto device, a digital twin definition. So you use the DSL, you define your basic generic models, you export that into Ditto for the runtime digital twin experience, and then Ditto can integrate with MQTT and other protocols directly, or you use maybe Hono as a high throughput message routing so that maybe not all of the messages are pertinent to what you're trying to achieve in Ditto in your digital twin. So you route only part of the traffic to Ditto that way in order to get the real-time data, just the real-time data that you need to your digital twin implementation. And what is great about Ditto is its maturity and its openness, in the sense that you can use it standalone, you can integrate it with other components in the Eclipse IoT ecosystem, and really it works well. And we've seen great adoption for it and great interest for it in the market.
Oh, awesome. Now, security is perhaps the most important aspect of IIoT. I mean, without security, there's technically no IIoT. So are there any open source software for IIoT security?
We don't have, apart from a few exceptions, we don't have specific projects that are strictly targeted at security. What we've seen is rather each and every one of our projects is paying individually close attention to the aspects of security that are pertinent to them. Okay. For example, we have implementations for all of the leading IoT protocols. So CoAP, we've got Eclipse Californium, both as a client and a server. Lightweight M2M, which builds on the top of CoAP. We've got Eclipse Lesson as a server-side component, and Eclipse Wakama as a client written in C. OPC UA, we've got Eclipse Milo. MQTT, we've got the Paho clients, the Mosquito broker, and now Eclipse Hamlin, which is IBM Watson IoT MQTT broker that has just been open source with us from IBM, and it's a highly scalable one that they will still offer in their cloud. So they are not just dumping the code with us, they are still using it. Anyway, so when you look at each of those projects, they are paying very close attention to the security standards in their space. So for example, DTLS is an important security protocol for CoAP and lightweight M2M. And the Wakama project, for example, is relying on Eclipse Tiny DTLS, a C implementation of it. Whereas in the case of Lesson, which is based in Java, it consumes Eclipse Californium, and Eclipse Californium as a CoAP implementation has its own support. I think it's Eclipse Scandium or something like that. I can be wrong there, but at least they have a specific subcomponent that addresses the security standards for CoAP. And then you look at Paho for MQTT clients. Obviously, there are specific, MQTT over TLS and, digital certificates and things like that. So each of those technologies has its own public standard that lives in a different place. And each of our projects is paying close attention to the security implementations that are relevant to them. And us at the foundation, our job is to ensure that they continue to do that, in the sense that whatever is the accepted security standard in the market, then we're trying to support that. And sometimes it means that we will collaborate with open source projects that are not necessarily at Eclipse. To give a great example, I told you about our Eclipse IOFog container orchestration platform. Yeah. And they had a problem. It's great when you have this central controller somewhere, but you want to distribute your edge nodes or your gateways all over the world, right? In your various factories, or even you want to put a node on every wind turbine that you are administering all over the world. Problem with that is, if you want to do that and get remote access to those nodes, it's complicated. You will have to establish VPNs, and so there was this great project at Red Hat that's called Project Scopper. And Project Scopper is a layer 7. So you remember the OSI model, so layer 7 application layer. So it's a layer 7 network proxy. So it's based on the Apache Cupid dispatch router. And essentially what it does, it enables you to bridge together Kubernetes deployments or other types of deployments over the public internet without VPNs. So what Eclipse IOFog did, they worked with the Scopper team to integrate Scopper in their base platform. So now you can bridge all of those fog nodes or edge nodes all over the place, over the public internet without VPNs and in a highly secure fashion, simply because IOFOG relies now on Project Scopper, and Project Scopper is written by bright networking guys at Red Hat.
Yeah.
So I think the approach there is really when we have to support specific security technologies because this is mandated by the specifications we implement, our projects do the job and they do it quite well. And then we're not networking specialists at Eclipse necessarily. I mean, infrastructure is something that lives at the Linux Foundation and in some other places. Yeah. So then we integrate and collaborate with other open source communities in order to really bring the level of security that people want in our Eclipse IoT solutions.
Awesome. Now that's quite interesting. Now, to close the session off, can you tell us about the vision, mission, and the role of Eclipse Foundation in general, and the Eclipse IoT in particular when it comes to industrial IoT?
Yes, absolutely. I think, you know, I kept repeating throughout our conversation this morning that open source is really important to industrial IoT. But you have to remember that not every open source project is the same, okay? In the sense, anyone can create a repo on GitHub and put it under an open source license. But then if you consume that code, there's no assurance of anything, right? The guy can get tired at some point or die, and then the project dies. And you have to remember that when you build an IoT solution, your whole solution is only as robust as the weakest dependency that you've got. And there are some, you know, scary things to be said about that. So not all open source is the same. So then, you know, it's great. Sometimes you will have single vendor projects from in the open source world like Spring or even the Go language, which is highly popular. But the problem with those, yes, it's open source, but there's one people calling the shots at the top. And that was Java's problem in the past, right? And the problem with that is that, okay, you care about it as a user, and then you need absolutely this feature. And you request it to the one, you know, making all the decisions at the top. And then they can say, nope, we don't care about that. You are on your own. So then, okay, you fork it, but that's not viable if you are a small organization. And so the real way to do open source is in a vendor neutral environment. Okay, where there's a level playing field between all of the players, whether this is Google, IBM, or Red Hat, or whether this is a much smaller organization. And then that's exactly what we do at Eclipse, right? We maintain a level playing field where essentially Eclipse open source projects are self-contained meritocracies. So they each have a project lead and a committer and a development process, and the Eclipse Foundation staff, I don't have any authority over the projects that I care about. I'm just there to ensure they follow our rules, but ultimately their technical direction and decision-making, it's all up to them, okay? And that's really important because then we have many members and we have our working groups where lots of large companies are a member, but working groups, they don't have authority over open source projects. They have a relationship with them, which means that yes, a working group can promote a set of open source projects like we do in Eclipse IoT, 50 plus open source IoT components there. But ultimately, you know, it's up to the projects themselves to do whatever they feel is right. So our approach at the Eclipse Foundation is really that we are community driven. Okay, it's really about the committers and the projects, and they do whatever they feel is right. And anyone can join, even if they are not a member. You can today submit PRs, pull requests to an Eclipse open source project, even if you are not a member of the foundation. But obviously, if those technologies are highly strategic to you, then maybe you should join because you need and you know, grow the community. Anyway, we are also code first. right? The simplicity in Sparkplug is an example of that, in the sense we don't care so much about abstract blueprints and architectures. We care about real world solutions with real customers, real implementers in the field. And then we are commercial friendly in the sense that we support a wide array of licenses that make commercial success possible. And we are all about open source, but open source that ultimately will create innovation at the top in the commercial space, so that people have to earn a living, and we know there's no actual free lunch, right? Yeah. Someone has to pay for things, so we are all about the commercial success. So that's the Eclipse approach. Now focusing on the Eclipse IoT working group. Eclipse IoT, as I mentioned, is about 50 projects, about 50 members. It goes up and down at times. Anyway, we are closing to the 50 member mark there. And what we are trying to do is to offer a great set of open source IoT building blocks that anyone can leverage on any cloud in any way that they want. That's literally the goal. And we've had, quite a good success on that. But more adopters are always welcome, and more contributors to the projects is always welcome. So essentially, it's my role as the program manager for IoT and Edge Computing to really keep an eye on those communities, see opportunities, seek new members, see new synergies, and obviously coordinate with the other open source ecosystems, because in the sense, we want to invent OpenStack or Kubernetes. We want to invent Linux. Those are great technologies and we need to build on them. So that's why we collaborate with the Linux Foundation, the Apache Foundation, et cetera, because we care so much about open source in general. And then at Eclipse IoT, it's all about our IoT building blocks. And they are not completely integrated, right? I'm not telling you, there are 50 projects, you go in a wizard and then it writes all the code for you and it's all magically integrated. Some hard work is required sometimes to integrate, but you've got the full flexibility, the full openness, and great community support from our contributors all over the world.
Awesome. Okay, so that brings us to the end of this episode. Thank you so much for coming on to the show and sharing such valuable insights with us. We wish you all the best with your organization.
Thank you so much, and certainly looking forward to see the next episode. The past ones have been great, and looking forward, to see what you have in store.
Awesome. Thank you.